We want to discuss the questions of the midterm. So first, let us look at question 1. Question 1, there are 10 students, and they take statistics. In this case, you got 10 scores because there are only 10 students, and in this case, we are dealing with those 10 students. So it is a population. It is not a sample. We are looking at exactly 10 students, and we treat them as population, not sample. But anyway, if you treat it as sample, you only got 1 point off. So in this case, it should be easy, right? You add them all up because x bar, it should be mu x, right? Mu x is equal to 1 over n summation xi, okay? And then you are also required to calculate variance, okay? Sigma x squared, that is 1 over n summation xi minus mu x squared. So basically you just plug in all the numbers, okay? Plug in all the numbers and you should get it right because the formula is here, okay? So the answer for that, mu x is equal to 77.5 and the variance is equal to 237.45. Is it right? Okay. But if you get some, you get 336 something, it doesn't matter. As long as you get the formula right and the number does not differ too much, you get a points. For each question is 10 points each. And since there are 2 sub-questions here, so it's 5 points each. Let us get to question number 2. You have mu x is equal to 42. And in this case, you got to pay attention to it because it said standard deviation, right? So standard deviation is equal to 5. So what does that mean? That means sigma x squared is equal to 25. Some of you forgot this, okay? Because what you get is standard deviation, and you are asked to get variance, okay? So you need to find this one, okay? And the first one is w is equal to 3x plus 2, okay? And you are required to get expectation of w squared, right? So basically what you're going to do, because this is w squared, so you have to plug square in here, right? So it's going to be 9x squared plus 12x plus 4, okay? If you can get to this part, everything should be fine, okay? Then you got 9 expectation x squared plus 12 expectation x and plus expectation 4. And you know that this one is equal to variance plus mu x squared, okay? It's 9 mu x squared plus variance of x, okay? And here it is simply 12 mu x, and here it is equal to 4, right? Okay? And here it is equal to 42, is that right? No, it is 42 square, okay? It is not 42. Some of you just plug in 42, that's wrong. It is 42 square. So 9 times 42 square plus this one, it is 25, right? It's 25. And plus 12 times mu x, that's 42 plus 4. So basically, you should be able to get it. And then the second question is VW, okay? VW, that is variance of 3x plus 2. As we have discussed this question before, plus 2 minus 2, does it affect variance? No, it doesn't, right? And 3 is here because it is a variance. So when you get this number out, you should get 3 3 squared, right? So it should be 9. 9 variance x. And just try to remind yourself, this one should be 25. It is not 5, okay? So it should be equal to 9 times 25. So basically, if you can get the formula right, okay, try to be very patient and plug in the right formula, you should be able to get it. So let's look at question 3, okay? Any questions so far? Number 1, number 2? Okay, let's get to question 3. Question 3 say PA is equal to 0.6, okay? And PA given B, that is equal to 0.6. And PB given A is equal to 0.3. The first question you have to find, okay? Find PA and B, okay? So we have this. Which formula should we use? We should use this formula and this formula, right? Because PB given A is equal to PA and B divided by PA, right? And this is equal to 0.3, right? And here you have to plug in 0.6. So what does that mean? That means PA and B is equal to 0.18. Very simple, right? And then you are required to get whether A and B are independent of each other. So there's only one criteria here, because if they are independent, then PA times PB will be equal to PA and B, right? So you already have PA, you already have PA and B, okay? You need to find PB, okay? You need to find PB. So when you want to find PB, you want to use this formula. So 0.6 is equal to PA and B and times PB, right? And that is equal to 0.18, and you are required to find PB. So from this equation, you know PB should be equal to 0.3. And at the same time, you know this one is PA, right? This one is PA. So you also know that PA times PB is equal to PA and B. So they are independent of each other, right? Okay. Some of you make mistake here. I kind of wonder why that is the case, because we already talked about if they are independent, this is the criteria that we use to determine whether A and B are independent. So basically you should be able to get it, but some of you make a mistake here. Okay, let's get to question 4. Any questions? Question 4. Question 4 say we have A, B, C, and D. We have 4 factory, right? And also, in this case, we are talking about quality control, and the manager, okay, or the QC member, QC staff, they are trying to get some samples out of all these factories and want to determine whether the product is good or not. And so in this case, the chance that this person choose factory A is 0.2, and factory B is 0.3, and then 0.4, and then 0.1, okay? So these are the probabilities that this person will choose A, B, C, and D. And then the probability of defection, okay, the rates of defection for A, that is 0.03, 0.04, 0.05, 0.06. So the first question asks you, what's the probability that if I choose one product from all these factories, what's the probability that this one is defective? Because this is the probability you choose A, B, and C, and this is the probability that it's going to be defective, right? So then the probability that it is defective and also is from A is equal to 0.2 times 0.03, right? And then the probability that is defective and from B is 0.3 times 0.04, and then the same thing, 0.4 times 0.05 and plus 0.1 times 0.06. So you get, how much is here? It should be 0.044, okay? Okay, the next question, what does it say? It says, if this is a good one, okay, it is a good one, it is not a defective, okay? So you want to read the question very carefully. Now we are talking about good ones. So for good ones, what's the probability that it's going to be good? It is not defective. So in this case, it should be 0.97, right? And 0.96, 0.95, and 0.94, okay? And we want to know, this one is already a good one, and what's the chance that it's going to come from A? So if you're going to put that down, it should be, this one is already a good one, right? Already a good one, and we want to know what's the probability from A, okay? So basically, all the same, what you want to do is, try to read the question and put the question into a formula, okay? So this is the formula you should get. And then you have probability that it is good, okay, and probability that it is A and good. Of course, what's the probability that it's going to be good? It should be this one times this one times this one, okay, and this one times this one, add them all up, okay, add them all up. So the sum should be the probability that are good. And what's the probability that it is good and in A? So it's this one, right? So basically, 0.2 times 0.97, okay, this is 0.2 times 0.97 plus 0.2 times 0.9, this is 0.3, okay, 0.3 times 0.96 plus 0.4 times 0.95 plus 0.1 times 0.94. Okay, so you should be able to get the answer. So that's it for the midterm. Any questions? No questions? Okay, as you may know, sometimes I may have done some mistakes. So if you have any questions on your midterm, we discuss during recess, okay? Let us get to continuous random variable. Okay, continuous random variable, that means basically it's a real number, okay, it's a real number. And we want to talk about uniform distribution. The same thing, right? For the discrete type, we say x is equal to 1, 2, up to n. And then you are required to find, of course, in this case, because it is uniform distribution, so P for any xi, the probability is 1 over n. But now we are talking about continuous type, okay? So this is different. We say x will be greater than or equal to A, less than or equal to B, okay? And since it is a continuous distribution. So what does that mean? And it's uniform, right? So that means for whatever number, they got the same probability density function. The height will be the same. So we have, this is the number x, okay? And here, the height is b minus a, okay, 1 over b minus a. And here it is a, and then here it is b. And then you want to be careful about the difference between continuous type and discrete type. When it is discrete, we can say, in this case, px is equal to 1, that will be equal to 1 over n, okay? And px is equal to 2, it is also equal to 1 over n. But now it is a continuous type. So if you say, in this case, px is equal to a, what is the probability? The probability is 0 because it is a continuous type. For any line or point, it has no area. If it has no area, then the probability is equal to 0. For the continuous type, you want to get to the probability, it has to be an area. Say this is A and this is A1, okay? So from A to A1, there's an area, you can find a probability. But for the continuous type, for any random variable equals a specific number, the probability should be 0. Because when I say x is equal to a, right? Okay? It is simply this line. Okay? For this line, does it have area? It has no area. Okay? So the probability is equal to 0. On the other hand, what you get? What you get is a probability density function. It's not a probability function. Okay? It's a probability density function. So what you get is the height of this function. It's not a probability. Okay, let us get to the mean and variance. Just try to get yourself familiar again with the formula. So if it is discrete type, we say mu x, okay, it is equal to expectation of x, and that is equal to summation x times px, okay? If it is variance, we call sigma x squared, and that will be variance x, and that is expectation x minus mu x squared, right? And what is this? This is equal to summation x minus mu x squared times px. That is for discrete type, okay, for discrete type. And now we want to deal with the continuous type. So then expectation of x, the same thing, it is equal to, okay, in this case, x times fx dx. And of course, for this function, it has a domain. The domain is from A to B. Okay, what means domain? Domain. Okay, there's a domain. Okay, so in this case, it's from B. It's from A to B, right? From A to B. And what is this? This is fx, right? This is fx, and we know fx is equal to 1 over b minus a. So this is because for any variables in this domain, I mean any number in this domain, the height is the same. So in this case, if the domain is from A to B, and this is a uniform distribution, okay, is a uniform distribution, then what you get, this is the probability density function. And so we just plug the function in this formula. So what we have, a, b, x times 1 over b minus a and dx. Okay? Any questions so far? And this is what we call definite integration, okay, definite integration. We have this number here, then we just calculate them and should be able to get the answer. Okay? Because this is x, right? So when we get it out, it should be x squared over 2, okay? Because it is x, so it should be x squared over 2. So when you get this, dx x squared over 2, what you get? You get 1/2 times 2 times x. And what is x? X is 2 minus 1, right? So if you have dx xn, you have n times x to n minus 1's power, okay? So here, b minus a, right? And this is from a to b, okay, from a to b. So what do you get? You get x squared over, okay, it should be b minus a, okay, 1 over b minus a, and 1/2 and b squared minus a squared, okay? So this is integration, okay, this is integration. So what do you get? You get b minus a and, 1 over b minus a, 1 over 2, and this is b plus a and b minus a. So you cancel this, so what do you get? You get b plus a over 2, okay, b plus a over 2. So if it is a uniform distribution, continuous type, the mu x is equal to b plus a over 2, okay? And of course, we know the domain is from a to b. Okay, so we get the mean, okay? Now we want to get to variance. So any questions so far? Any questions so far? Okay, so let's get to mean, okay? Variance, okay, variance. Variance is Vx, right? And that should be this will be easier for us, okay? Because this one is actually x minus mu x squared times fx times dx, right? Variance of x, the original definition is this, okay? But of course, we can simplify this form, okay? The simplification we get is this part, okay? After we simplify it, we get this part. And since we already know mu x, right? We already know mu x, so this will be easier for us. And so we will start from here. Okay, any questions? If you are not familiar with integration, you want to brush up upon it, okay? You want to review some of the integration here. Okay, so we have b a x squared times 1 over b minus a dx minus b plus a over 2 squared, okay? And so it should be x to 3's power, okay, x to 3's power divided by 3 and divided by and times 1 over b minus a. And so it is from a to b minus b plus a over 2 to 2's power. Okay, so what do you get? You get b minus a and 1 over 3, and this one will be b to 3's power minus a to 3's power, and minus b plus a squared. So this is 1 over 3, okay, and this is a squared plus b squared plus ab, okay, and then minus 4a squared plus b squared plus 2ab. Okay? Any questions so far? Okay, then we want to use this part of the blackboard. We have to find the least common multiplier here, okay? So 3 and here is 4, so it should be 12. Okay? Then in this case you have 4a squared, right? Because we use 12, right? And you have to time it by 4. 4a squared plus 4b squared plus 4ab, and then minus, you want to remember here it is negative, okay, negative, and this is positive, positive, positive. So negative, positive, you get negative. Okay, the same thing there. So it should be minus 3a squared minus 3b squared and minus 6ab. Right? Any questions so far? So then what do you get? You get 1 over 12 a squared plus b squared, okay? 4 minus 3, you get 1. 4 minus 3, you get 1. 4 minus 6, you get negative 2. Right? So what do you get? You get a minus b squared divided by 2. And what is this? That is the variance. So variance of x squared is equal to b minus a squared, or a minus b, that's the same thing, okay, divided by 12. So for the continuous uniform distribution, we get the mean, okay, is equal to b plus a over 2, and this variance is sigma x squared, that's b minus a squared divided by 12. Any questions? Okay, then after this we want to get to normal distribution. Normal distribution is a distribution we use very often, okay? And basically from this point on, we will devote a lot of time to normal distribution. Okay. So normal distribution. Basically, the diagram looks like this. Okay? It is called bell shape. Because it looks like a bell, okay? It looks like a bell. And this distribution, the density function, probability density function, has several characteristics. First one, the highest point, okay? So the maximum value occurs at this part, mu x, okay? So if you get to the variance, okay, so fx is equal to mu x, this one has the highest value, okay? This one has the highest value. The highest value is here. Okay, then the second characteristic is that it is symmetric. What does that mean? Because when we say it is symmetric, it means this side is exactly the same as this side, okay? Two sides if you fold them all up, it is like a mirror, okay? It's like a mirror. Okay, if you look at a mirror, you look at yourself, right? The same thing, exactly you. But what's going on there? The right side turns to the left side turns to the right side, okay? So basically, this is a mirror image, okay? So if you have, say, here and here. So let us say this is mu x minus sigma x, and here it is mu x plus sigma x. Because the distance from this point to the mean and from this point to the mean, the distance is the same, okay? If the distance is the same, then what you get? You get this one and this one, you will be at the same height, okay? And this applies to all the curves, so that's why we say it is symmetric. And another point is that when you get to mu x plus sigma x and mu x minus sigma x, you get an inflection point. Inflection point, what is that? Let's say this, okay, inflection point. So what's the characteristic of inflection point? When you get inflection point, basically at inflection point you get f double prime is equal to 0, okay? F double prime is equal to 0. Okay, of course there are some other characteristics of normal distribution, but now we will talk about something else. Okay, in any case, as you may know, mu x may be different, right? And sigma x squared may be different too. Let us take a break. We just mentioned that for normal distribution, it has several characteristics. One is symmetric, okay, it's bell-shaped, and of course the domain is from x from infinitive to negative infinitive, okay? And what's the probability density function of normal distribution? It looks like this, okay? Fx is equal to 1 over sigma x square root 2 pi and e 1 over half, 1 half x minus mu x sigma x squared. So this is the probability density function of a normal distribution. Of course, the same thing, it has to satisfy the criteria of a probability function. It should be fx, okay, greater than or equal to 0, okay, because it is a probability density function, okay. If it is a probability function, then it is px less than 1, less than or equal to 1, greater than or equal to 0. And summation px must be equal to 1. And here, because we talk about probability density function, so if it is greater than or equal to 0, that's just fine. And then you have to have integration that is the same thing as summation. Fx dx should be equal to 1. For normal distribution, this is very hard to prove, okay? But if you want to learn how to prove it, there are some textbooks that with all the process of proving this, okay? You can check that if you want to. Okay, then we just mentioned some of the distributions, even if it's normal distribution, they have different mean variance. Okay, so in this case, no matter what's the difference, we will be able to standardize it. But let us talk about some of the difference here first. So these two normal distributions, basically they are the same, okay? But what's the difference? One is mu x, one is mu y, and this mean is larger than this mean, okay? What about this one? Okay, apparently you can tell they have the same mean, right? The mean is the same, but which one has higher variance? A or B? Which one has higher variance? A or B? Which one has a higher variance? Which one has higher variance? B, right? B is spread out more, right? It's spread out more. So B has higher variance and A, the variance is less, okay? Now, we want to talk about the process of standardization. Because in these cases, you know, they are all normal distributions, but the mean may be different, okay, and the variance may be different. But in this case, we want to standardize it. So we call standard normal. We have standard normal, okay, standard normal distribution. So Z will be equal to x minus mu x divided by sigma x. Okay, so if x is a normal distribution with mean mu x, variance sigma x squared, then Z, okay, is a standard normal with mean equal to 0 and variance equal to 1. Okay, so basically this is what we gonna use. Okay, what we're gonna use is this one. But of course, when you deal with all the questions, it will be a normal distribution. But if you want to know the mean, okay, and the variance, okay, and to apply a standard normal table, you have to first standardize it, okay? You have to first standardize it. And we will check some examples. And the benefits for standardized normal is that we have a table to calculate the probability. So you don't have to calculate it. There is already a table. You check the table, then you can find the probability. So first, let us get some example, okay? And really, there are some of the numbers that we often use. So that is, the corresponding Z, okay, and the corresponding probability. Okay, let us get to that first. So if P, okay, of Z, okay, so we want to find the probability between 1 and negative 1, okay, as a matter of fact, this probability is equal to 0.683, and the probability between 2 and negative 2, that is equal to 0.954, and probability Z 1.64 and negative 1.64, what you get? You get 0.90. Z between positive 1.96 and negative 1.96, that is equal to 0.95%, okay? And then P z between 2.58 and negative 2.58, you get 0.99. P when it's between 3 and negative 3, that is equal to 0.997. Okay? So hopefully you can memorize this, but you don't need to worry too much about it, because for the second midterm, you will be given a table. Okay, you will be given a table. And now let's look at how to use that table. So let us say we want to check PZ is less than or equal to 1.05 and greater than or equal to 0. Okay, what is the probability? So please take out your book, okay, and turn to page 758. Okay, check the book and turn to page 758. Okay, so this table shows you you can check the number z, right? Okay. 758, the number z there. And what does it tell you? Okay? The area, if you look at, there's an example, okay? There's an example in the book. Say, if z is equal to 1.96, then probability z, 0 to z, will be equal to 0.475, right? To check it. So because you are interested in 1.96, so you look at the first column, right? The first number 0.0, the second number 0.1. But in this case, you are interested in 1.96, right? Okay, so you check. So you get 1.96 from the first column, you check. But what do you get? You get 1. So what's the probability? Okay, first you check z 0.0, right? First you have to check 1.0. And then you have to check the second decimal point. The second decimal point is 0.05, right? So you have to check this one to 0.05. So you check this one is 1.0, okay? And here is 0.05. So this number will be the probability you are looking for. So can you tell me what's the probability? Could you speak louder? You can speak Mandarin, but speak louder. How much should it be? 0.3531, right? 0.3531. Okay. Okay, let's try once more. One more. Let's try one more. P Z and 2.12. 林真竹 2.12. So it should be 0.48. How much? 30, right? 0.4830. So you get this one 2.1, right? 2.1, and this one should be 0.02, and then you get the number. Okay? Any questions? Can everyone get it? Let's try one more. Okay, Xu Fangyan. We want to find this probability between 0 and 0.65. Okay, right? Because in this case, you look at 0.6, right? And then here you look at 0.05, okay? Because you look at 0.6, that's the first decimal digit. And then you look at the second one. So that would be 0.2422. Okay? Any questions? Now, because, as you may know, it will not always be positive number, right? And what about this? Okay. In this case, it is Z between 0 and 0.65, right? But what is Z greater than 0.65? So what should be the probability? .65. That's try this one again. Okay, it is greater than negative 0.65. Okay, the first question we have is between 0 and 0.65. And we just deal with Z greater than 0.65. And now we want to know the probability of P of Z greater than negative 0.65. So you want to practice all these, okay? You want to draw a diagram. You should be able to, you want to learn to the point that you can draw the diagram, okay? So that you understand which area you are talking about. Now we are talking about z greater than negative 0.65. So negative is on this side, right? Because the mean is equal to 0. And it should be negative. This part, okay, plus this part. If you check the table, can you get P of z less than or equal to 0 and greater than negative 0.65? Can you find this number? No, you cannot, because the table only tells you positive number. But as you may know, okay, we already talked about it. It is symmetric, right? It is symmetric. So if from 0 to 0.65 is equal to 0.2422, what about here? Negative 0.65. What should be the area? What's the probability? It's the same thing. It is equal to 0.2422, right? So in this case, we want to know the area that is greater than negative 0.65. How much should it be? It should be equal to 0.2422 plus 0.5, right? So it should be equal to 0.7422. Okay? Any questions? And the same thing. If you want to know Pz less than negative 0.065, okay, what should it be? In this case, this is negative 0.65, right? Which area we are interested in? We are interested in this area, right? Okay? Then the same thing. How much it should be this area? It should be 0.5, right? And this one we already know is 0.2422. So that will be the same thing there. Okay? Any questions? Okay. So if you still have questions on checking the table of normal distribution, please raise your hand. Any questions? Okay. So now let us get to some example here, okay? Okay, so let us say X is a normal distribution. The mean is equal to 20. The variance is equal to 4, okay? And now you are required to find out X greater than or equal to 24, okay? So basically, we know it's a normal distribution. Of course, you can check normal distribution table. But we only have the table for standard normal. So in this case, whenever you get X, okay, whenever you get X, you want to find a way to change X into Z, okay? So the question is, find the probability of X greater than or equal to 24, okay? It will be hard to find because we only have standard normal table. So we have to change X into Z, okay? And how to change that into Z? As you know, Z is equal to X minus mu X sigma X, right? So this one should be this, right? Because X, we want to turn X into Z, right? and here it is x. So this x is equal to 24, right? This x is equal to 24. So 24 minus mu x is equal to 20, right? And remember, this is sigma x. It is not sigma x squared. This is standard deviation. This is variance, okay? So then it should be 2, right? So then PZ greater than or equal to 2, right? Because it's 4 divided by 2, we get 2. So let me get to another person. Zheng Yupei, find the probability of this. Could you speak louder? Are you sure? Are you sure? So it should be 0.5 minus 0.4772, right? Because from 0 to 2, it is 0.4775. That's from 0 to 2. We are talking about greater than or equal to 2, right? So then it should be this, 0.0228, okay? Now let us get to another example, okay? Now we want to find probability of x greater than, less than or equal to 24, greater than or equal to 16, okay? Of course, in this case, you don't have a table about this distribution. We only have a table about standard normal. So you have to turn it into z, okay? P and then z, right? So in this case, the same thing, right? X is here, okay? Plug in here. So 24 minus 20 divided by 2. And here, that's 16 minus 20 divided by 2. Okay? Any questions so far? So in this case, what do you get? You get P negative 2 less than or equal to Z, less than or equal to 2. So what should that be? The probability will be, can anyone tell me this? Huang Xiangyu. You already have this one here, right? What should it be? So it should be, could you speak louder? So it will be 2 times 0.4772, right? Because you have one side is equal to 0.4772. You have two sides actually. So what you get? Okay? Is that right? Okay, any questions? Now let's get to one more example. If let us say we have 1,000 samples, okay? So let us say we have a sampling, okay? We take samples out of a population. And we know the probability that it is between 24 and 16, that is equal to probability 0.9544. And now the question is, if I have 1,000 samples, okay, if I have 1,000 samples, how many will be between 16 and 24? Okay, this is the same question. We already find the probability, right? This is the probability. Now, the question is, I have 1,000 samples. how many samples will be in this area, okay? The first we find is the probability, okay? Now I want you to tell me what's the number. How many samples will be in this area, within this area? If you remember, what is probability? Probability is relative frequency, right? Probability is relative frequency. And now we want to find the frequency, okay? So relative frequency is equal to the number you have, right? The number you have and divided by the total, right? And here you already know what's the relative frequency here. The probability, right? That's 0.9544, okay? And how many will be in this area? You don't know. But do you know the total number? There's 1,000 samples, right? 1,000 samples. So how many samples will be between 16 and 24? 954.4. So it will be about 954 samples within 16 and 24, okay? So sometimes we ask you about probability, okay? Sometimes I ask you about the number. So you want to be careful here. If I ask you about a number, you tell me the number. I ask you about probability, you tell me about the probability, okay? Any questions so far? Okay. Questions? No. Okay. Since we already talked about binomial distribution, so we want to get some review of binomial distribution and also the relationship between binomial distribution and normal distribution. So when the number n, that's the sample, when sample gets very large, okay, when you have a lot of samples, then binomial distribution will be approximated by normal distribution. So what does that mean? If you have a lot of binomial distribution, I mean the sample size is very large, what you get? You can get a normal distribution, okay? You can get normal distribution. So let us check this example, okay? And still you want to remember what's the mean and variance of a binomial distribution. It should be NP, and here it is NPQ, okay? So this is the mean and variance of a binomial distribution. Now let us get to the example, okay? Okay, so let us say this example, okay? So we have a machine, okay, machine can produce a lot of products, and the defective rate is 0.2. Okay? The defective rate is 20%. And so now X is the number of defective products. So first question is, what is the probability of X? Okay, what's the probability of X? Of course, you want to remember, we get 100, okay, we get 100 samples. We get 100 samples. And this sample is large, okay? Basically, this sample is large. So there are two ways to deal with this question. First one is by the binomial distribution, okay? You can deal with it by binomial distribution. The second one is to use normal distribution, okay? You can use normal distribution or binomial distribution. Let us look at the binomial distribution first. So we take out 100 samples, and the defective rate. So probability of X. Probability of X, okay? Then we have to deal with it again by normal distribution. So we already know binomial distribution, okay, the mean is m. And p is equal to 0.2. So how much it should be here? It should be 20, okay? Okay, we're looking for this. We are looking for, we have chose this, take a break.